This is the Math 1113 Zoom meeting for Friday, November 13th. And we will start off working some problems here then from section 7.3. Go through some examples. Start, say, with, why don't we start, say, with number 7 here. Well, I don't know, number 9. We'll go down to number 9 there. So page 597. Problem 9 is 7.3, problem 9. Tangent of x is -1/3. Cosine x greater than 0, which means your x coordinate is greater than 0. And we're supposed to find all three things. 2x cosine 2x tangent 2x. So if the tangent is negative, but your x-coordinate cosine is positive, you have to be in quadrant 4. Quadrant 4. Which puts, remember this is y over x, which puts your y at -1, your 3 on that leg, and this would be the square root of 9, 3 squared plus 1, square root of 10. Sorry. -1 squared, which would be the square root of 10, the radius. All right, it's more of a project than a problem. A sine of 2x then is twice cosine x. Your sine x is -1 over root 10. Your cosine x is 3 over root 10. Plugging and chugging twice, -1 over root 10, 3 over root 10. We're just going to put a -6 over 10, -3/5. Double the angle, your y coordinate at double the angle is -3/6. That's what this says. The y coordinate at double the angle -3/5. Those parentheses there. All right, try cosine of 2x. Oh, we have a participant.
Good morning.
Is Mr. Pianetta?
Yes, sir.
Okay. Yeah, I was just charging in to work some of the problems here. You got any questions?
Yes, sir. I'm pulling it up. I'm pulling it up right now.
All right. Well, I'll finish the cosine of 2x and check back with you and see if you've got it.
All right, sounds good.
Okay. Cosine squared of x minus sine squared of x. Cosine x again, 3 over root 10, quantity squared, sine of x -1 over root 10 squared. We're looking at 9/10 minus 1/10, which is 0.4. So that's the x coordinate. Double the angle. Is equal 0.4, 8/10. This would be a -0.6. Have you found your question?
Yeah. First question is, let me see. It says here, find sin of 2x and cosine of 2x and tan of 2x from the given information.
Okay.
And then it says cosine of x equals 12 over 13. And then there's a comma separating cosecant of x, and it's going to be less than 0.
Okay. This is off WebAssign.
Yeah.
Okay. Yeah, this is basically off the first section of homework I'm just doing here. So you want to see cosecant of x less than 0. That means a sine of x would also be less than 0 because you flip things, you don't change sign. So you're going to be basically your x coordinate is positive and your y coordinate x is positive. And I don't mean the same x. This is angle. This is the x coordinate. Cosine of an angle, don't get confused by the letters, means your x coordinate is positive and your y coordinate, sine is y coordinate, cosine is x coordinate, less than 0. So what your x is positive, but your y is negative. You see that's going to be quadrant 4.
Yeah.
So yeah, x is positive, y negative. That means you're quadrant 4. So your cosine is going to go adjacent over hypotenuse. And can you tell this leg is -5, or do you need to see it written out?
Could you show me it written out, please?
Yeah. So y squared there, add 12 squared would be 13 squared. Y
Oh, you're just using the Pythagorean to find
yeah,
that?
Pythagorean
Oh, okay.
theorem. 5, 12, 13 works out full integers.
All right.
You're going to have 169 minus 144, that's 25, but you want it -5. So your y squared will be 25, y will be plus or minus 5. You're going to want negative because you're in quadrant 4. All right, you ready to charge in? Seem to keep it all
Yeah.
on one page. All right, well, it's really just plug and chug. A sine of 2x is twice the sine of x cosine of x. Now, they've already given you cosine of x. That was given. From the triangle, your sine of x is going to be a -5 over 13. Opposite over hypotenuse. I'll rewrite the cosine of x was given to be 12 over 13. It's freezing. Okay. And so, yeah, just plug and chug. Twice sine is -5 over 13. Cosine 12 over 13. You're going to get -120 over 169. -10 times 12, -120 over 169. All it means is your y coordinate, because it's sine, it's a y coordinate, but you've doubled the angle. Your y coordinate at double the angle is -120 over 169. I don't know if I should write that down. Y coordinate at double the angle -120 over 169. Do we need to pause for station identification or?
No. Well, you're saying that so sin of 2x this equals the -120 over 169, or does that have to go like further?
No real way to go further unless you want to, divide it, get a decimal.
All right.
These don't seem to reduce.
Yeah.
Are you ready for the cosine?
Yeah.
Okay. There's 3 versions of that formula. I'll just use the first one, cosine squared of x minus the sine squared of x. And again, you're plugging in the same sine and the same cosine. We're 12 over 13 squared, subtract a -5 over 13. squared. 144 over 169, subtract 25 over 169. Minus 25, I think it's 119. 119 over 169. This is your x coordinate at double the angle. If it'll catch up, there you are. So it's really a matter of working your way around the triangle, being able to write down what you need for these formulas and plug and chug into the formulas. I know that's easy for me to say. I've seen the formulas for almost 40 years now.
Yeah. Yeah.
So I don't know if you're brand new to it, if you took this, a little bit of this in high school, but may read like gibberish.
A little bit, but not too much.
Okay. Are you ready for the tangent of 2x?
Yeah.
Now, you really have a couple choices. There is a straight formula for tangent of 2x. We could use that. I'll write it down. Yes, they've already eaten. It was twice tangent x over 1 minus tan squared. All right, this is sort of method 1. Method 2 is a sine of 2x over cosine of 2x. And they've already had you do sine of 2x and cosine of 2x, so we could just simply divide these. I tried to show this on the video Tuesday. Method 1 works a lot out, but it works out a lot longer than method 2. Do you have a preference?
No, not really.
Well, we'll do the short way then, I guess. Sine of 2x is negative 120 over 169. Cosine of 2x was 119 over 169. Negative 120 over 169 times 169 over 119. You remember this flips. And you wind up with negative 120 over 119. One other thing you can notice your sine and cosine are less than 1.
Yeah.
Your tangent doesn't have to be. Your tangent can be anything. It just means your y leg is pretty much greater than your x leg, even if it's in a negative direction. Your y is very slightly longer than x. Got the next one?
Yeah, this one says use the formulas for lowering powers to rewrite the expression in the terms of the first power of cosine.
Okay.
But then this question says like as an example 4, but like there's no like example 4, so I don't really know what that means.
Yeah, I don't really know either. Let's see if I can find an example 4 here. Well, I guess technically they're referring to this.
Oh, okay.
But I don't know if they're using the exact same formula or expression. So if you want to give me what they have for you, I can.
They got a cosine of 2, cosine squared of x, and then sin to the 4th of x.
Okay, this is going to be here a while. It's a bit of a project. We're going to lower powers. All right, so what we're using, that a cosine squared of x is 1 plus cosine of 2x over 2. And a sine squared of x is 1 minus. See how the power is lower?
Yeah.
Squared here, but only 1 here. Both of them use
Yeah.
cosine of 2x. If you want to know, I'm getting it's right above example 4.
And what page is that?
These are on page 592.
All right. Thanks.
So the cosine squared directly plugs in Shugs. Plus cosine of 2x divided by 2. That's your cosine squared of x. Now your sine to the 4th can be written as a sine squared squared. There, and when you raise, your 2 times 2 is 4. So you're getting 1 minus cosine of 2x divided by 2 squared. Pause for station identification. I'm sorry, I didn't draw the fraction line through the whole thing on the first. That was inaccurate. Make sure you draw your fraction line through the whole thing here. It's not.
Over 2?
Yeah, see how I've drawn the fraction line through the whole thing now?
Yeah.
I noticed I got a little slack. I was only really showing the 2 under the cosine. That's not right.
Okay.
Okay, any questions about this setup?
No.
So yeah, this is your sine squared directly, but then you got to square it because it's to the 4th power. All right, are you ready for all the algebra? The rest of this is nothing but gibberish algebra.
I guess so.
Okay. Basically, order of operations, you're going to do this exponent before we can multiply. So that means we've got to FOIL this. So we've got 1 plus cosine of 2x all divided by 2. 1 minus 2x, 1 minus cosine of 2x. That's all divided by 4. I just wrote this out twice, copied it twice to show the squared, and then we're going to FOIL it.
Okay.
And then, yeah, you can go, the 2 and the 4, if you want to get rid of those. Those can be, say, a 1/8 in the front. Cosine of 2x. 1 minus cosine of 2x minus cosine of 2x plus cosine squared of a 2x. In fact, this is directly problem 2. We can check the answer on this. This is actually problem 13 out of the book directly. They just put it on WebAssign. This is from WebAssign. Problem 13. Problem 13 in book. We can check and see what form of the answer we get. Are we ready to combine like terms?
Yeah.
1 plus cosine of 2x. 1 minus 2 cosine of 2x. See, one of these minus -1 minus one of them, -2 of them. Plus cosine squared of 2x. All right. Yeah, it's hard to know exactly how far to go and where to quit. We're ready to plug in for a formula here. Remember, the whole point of this is to lower powers. So let me point this out. Cosine squared of an x was 1 plus all divided by 2. Cosine squared of a 2x. You see how you get it? You got to sub in everywhere there's an x, you put a 2x. So you're going to get a 1 plus cosine 2 times a 2x. Well, that means 1 plus cosine of 4x divided by 2. The point being, your angle doubles. In the basic formula, they show you going from x to 2x, it doubles. So if you go from 2x here, you're winding up with an angle of 4x, it doubles.
Oh, okay.
It'll catch up. There we go. Okay, are we ready to plug this in? See, this goes up there. And then I have everything
Okay.
cosine for first power. This is a bit of a mess. Bit of a project. I can keep both. Okay, if I keep both on. So we have the 1/8. We have a 1 plus cosine of 2x. We have 1 minus 2 cosine of 2x plus 1 plus cosine of 4x, and that's all divided by 2.
It's not showing up on my screen what you're writing. It's like a little frozen.
Okay,
Oh, there we go.
okay.
Catching up.
All right, well, I can spread this out and then we can go ahead and do a FOIL. Minus 2 cosine, it's not catching up. Right in the next line, but it's not catching up, is it? Plus 1/2 plus, say 1/2 cosine of 4x. Okay, there it is, caught up. No, it didn't. No, it didn't. That 1 plus cosine of 4x over 2, I've spread out. It'll write the next line. I'll stop for it to write the next line. It will. Things are freezing up. Okay, it's trying. Not working like a well-oiled machine. Okay, there we are. We can compare the two lines. I don't know if I should break it and go back to it. Sometimes that helps. Okay, here we are. See what I've done?
Was that? I'm sorry.
All right, on this last, it's not showing it. Okay, on this last term, see how I
Yeah.
start out the 2? There's 1/2, and then there's 1/2 cosine of 4x. Yeah, I'm trying to get the second parentheses as simple as I can. See how I have 1 plus 1/2? Maybe I should just break this. Let me just go ahead and stop the share and restart it and see if it works better. Sometimes it does.
Hello?
Can you hear me? I'm here. I'm trying to talk to you, but apparently you can't.
Now I can.
Now you can? Okay. Let me
I
stop.
hear you now. Yeah.
Okay, let me stop the share and
Do you hear me?
yeah, I can hear you now. Let me stop the share and go back to it and see if that resets things. Sometimes it does, sometimes it doesn't. Because this is working really jerky.
All right.
Okay, I'll be right back to it.
Yeah. No problem.
Okay. Okay, let's see if that works any better for a while. All right, I'm trying to get this second parentheses as simple as I can. So you see I still have a 1 plus a half.
Yeah.
That's going to give me a 3/2 because 1 is 2/2. 2/2, 1/2 will give me 3/2. So let me do that. Three halves. 2x plus 1/2 cosine 4x. All right, all we got left to do is a massive FOIL here. Are we ready to charge in?
Yes, sir.
All right, 1/8. 1 times 3/2, 3/2. 1 times, you have a -2 cosine of 2x. 1 times this is this. 1 times that, you have a half cosine of 4x. It's round 1. Cosine of 2x, then round 2 is distribute cosine through the whole thing. 3/2 cosine of 2x. All right, now notice I'm going to get a -2 on this times this. I'm going to get a -2, a cosine squared of a 2x. Oh, that's great. That means I got to reduce that. And then the last piece is going to be a half plus a 1/2, a cosine of 2x, a cosine of 4x. All you can do is write those together. But a cosine of 2x, that's a cosine squared of 2x. I'm going to look for any like pieces here just to boil stuff down before I reduce this. Golly, these are projects. 1/8, 3/2. All right, you're going to have a -2 cosine of 2x, a positive 1.5 in effect, positive 3/2. That's going to give you a -1/2 cosine of 2x. Plus your 1/2 cosine of 4x. Minus 2 cosine squared of your 2x. Plus your 1/2 cosine 2x, 4x. All right. You see, I've got a sub in here to lower that power. If I bring the page back, you remember that brings back this 1 plus cosine of 4x over 2. Well, I'm going to put in 1 plus cosine of 4x divided by 2. I don't know if you've got the patience for this, if you'd rather see something else. If we actually,
Yeah, it's
we actually get to the right answer on this, you will have witnessed a miracle. You want to switch to something else?
right.
I'm
Yeah.
sorry, go ahead.
Yeah, that one is pretty crazy.
Okay.
This one right here says, this one right here says, use an appropriate half angle formula
Okay.
to find the exact value,
Okay.
and the expression is sin
Okay.
of pi over 12.
Okay. I'll write out the formula. Basically, you got to express this as a half angle. That's like an x over 2. The book uses a u in their formulas. I guess I like x. All right. That's a plus or minus a square root of 1 minus a cosine of x, all divided by 2. See the crazy crap I have in my head?
Yeah.
Just to make sure, let's double check it. Book again is using u's. Here you are. Book uses u's. Plus or minus square root 1 minus cosine. And the point being, they call this a half angle, and then this is double. When you have a half u, double
Yeah.
it, straight u. All right, but I'm using x. All right, so the trick is to figure out what your x is. Well, when you match this to this, and x over 2 equals pi over 12. Multiply both sides by 2. 2 times pi over 12. And the x has got to be pi over 6. And you see pi over 6 is double pi over 12.
Yeah.
That's what this says. Use cancel here. So you've got plus or minus square root 1 minus cosine of pi over 6 over 2. Well, a cosine of pi over 6 off the circle, that's 30 degrees. Your cosine, first quadrant, 30 degrees is shallow, x leg is long. That's root 3 over 2. So you have plus or minus big square root 1 minus root 3 over 2 all over 2. That's usually, well, you got to pick the plus and minus. And cosine pi over 6 is first quadrant. Okay, actually, that's not where you pick it from here. Sine of pi over 12, this is first quadrant. Quadrant 1, sine is positive. Read it. So we have plus sine of pi over 12 plus square root 1 minus root 3 over 2 all over 2. Now the book, well, I don't know if it's off WebAssign, but WebAssign will probably want this simplified. You want to see how it's simplified?
Sure.
Okay, well, your 1 is 2 over 2 to create a common denominator with this. So you're getting a big square root 2 over 2 minus root 3 over 2 all over 2. It's all under the root. The big square root of 2 minus root 3 all over 2 over 2. You can crush this together to be all over 2. All right, so, well, that's a big square root of 2 minus root 3 over 2 times 1/2, because you're flipping this, which means you're at a big square root of 2 minus root 3 all over 4. All right, but then that square root on that 4 leaves you 2 outside. So finally, it's a big square root of 2 minus root 3, and that's all over 2, which is out of the root. Write it better over here. Square root of 2 minus root 3 all over 2. Be your sine of pi over 12. In the regular class, I don't make people get this far. I usually let them quit right here.
Yeah.
But if this is a WebAssign, probably won't like that answer. Positive because it's quadrant 12. I'm sorry, quadrant 12. Quadrant 1. It's positive.
Yeah, I was like,
Yeah, quadrant 12. I guess I saw that 12 and had a brain fart.
yeah,
Okay.
it's cool. Next question I got here.
Okay.
It's write the given expression as an algebraic expression in X.
Okay.
And it says sin of 1/2 inverse of cosine of X.
Okay. Well, again, this is using a half angle formula. If you want to call this a theta, you're matching it to a sine, say a theta over 2, or I could use u over 2 if you wanted to directly match what the book is u. And what I just wrote that down. Maybe I should have used x over 2. But yeah, but I don't want to confuse. I didn't use x because I didn't want to confuse you with this x. But yeah, plus or minus square root 1 minus cosine of theta all over 2. Okay, so there's sine of this theta over 2. See, your theta is arc cosine of x. So in effect, you have sine of arc cosine of x over 2. So your angle is directly arc cosine of x, and it's a half angle because they're dividing it by 2. All right, so sine of theta over 2 here then is your plus or minus big square root 1 minus cosine of arc cosine of x all over 2. Cosine. We need to pause for station identification.
No, you're good.
Put this in brackets, put this in bracket. Well, this is a nice, easy cosine of your arc cosine then is just going to cancel and give you x. 1 minus x divided by 2. They don't really give you enough information to choose whether it's plus or minus. I guess we'll just use the positive. So I'm getting big square root of 1 minus x all divided by 2. Hope it likes that.
The 1 minus square root of over 2.
Yeah, square root, and all underneath is 1 minus x divided by 2.
These next two questions involve it says write the product as the sum,
Okay.
and the two different equations are 9 cosine of 8x, cosine of 11x. And then the other problem is sin of 2x minus sin of 5x. There's two different problems that I have, but they just involve the same thing. So,
Right. Okay, so they look like this.
Yeah.
Okay. Well, these are straight plug and chug, but I have not filled my brain with this useless information.
Right.
Yeah, this is called product to sum. Page 595. I think I derived the first one of these on Tuesday. You can plug in for the formulas from 7.1 or so, maybe 7.2, I think 7.2, and show that this will dissolve back to this. But yeah, these, you've got to pick your whatever product they're giving you, and then it expands out like this.
Yeah.
So this is a cosine times cosine, which is the third one. So I'll write it out using these here. This says cosine of u, a cosine of v is a half cosine of u plus v plus cosine of the difference. So you see where I'm getting that?
Yeah.
So your u is the 8x and your v is 11x. U equals the 8x and v equals 11x. So it's really just plug and chug, a half cosine of 8x add 11x, add cosine of 8x minus 11x. Don't forget the 9. I'm sorry. Should be a 9 in front of all that too. There was a 9 coefficient. The direct products of the cosines are this, starting with a half, but this one had a 9 in front, so there should be a 9 in front of all that. So that makes 9 halves. All right, so 8x, 11x, that'd be 19x, right?
Yeah.
And 8x minus 11x would be a negative 3x.
Yeah.
Now, the book or WebAssign probably won't like that. You're supposed to remember, I don't know if you do or not, that a cosine of a minus x is equal to a cosine of x. Cosine is even, which means you can just ignore this. Meaning you get 9 halves, cosine of 19x, add a cosine of 3x. And quit. I'll give people, oh, that's a cosine of 22x because they're adding 19x and 3x. Okay. Don't do that if you want good grades. Is that too fast?
No, that really wasn't.
Okay. Are you ready for the next one?
Yeah.
Well, this is called basically sum to product. Even though, it's technically a difference, they generically call them, so you can put a plus and negative. All right, so let's see, I should have written the formula. This is page 595 up here. These are on the next page. Oh, I want to stay. Let's see if we're back. Okay. You got to, again, pick what you're matching. This was a sine minus sine, which is number 2. Oh, I'm freezing again. Can you hear me? Well, it worked for a while. Okay, quit on its own.